All right. I think we're just going to get it started. Thank you very much for coming to this breakout session. I hope everyone enjoyed the wonderful keynotes. It was really incredible keynotes and very long as well. But I hope you really enjoyed all the demos and the exciting progress there. It's a Build conference. It's really for Microsoft developers. So in this breakout session, my colleague Ryan and I have a chance to tell you the exciting stuff and the tools and the APIs, SDKs we're actually building to add the smarts to the data and to the apps you are building. This is the title of our talk. As I mentioned, that Ryan and I would do this presentation together. Just a friendly reminder that we really want to get your feedback for every session, every presentation we do. At the end of this presentation, it would be great if you can submit the evaluation, and please say Ryan did a good job. Yeah. So we are going to talk about something called the Project Oxford. It's really very early for what we actually can really do in terms of adding smarts to the data and the applications you have. Specifically, what we are going to show you today is a portfolio of REST APIs and SDKs that will help you to write applications when you deal with massive amount of data, especially the kind of multimedia data from speech, voice, to image, video, to text. How can you actually understand what's going on with the content you have, the multimedia data, and how can you make some sense out of that? As many of you are aware, recently it's just so much explosive growth of online data that a lot of us can get access to. If you build apps, if you really care about all those mobile devices, now just everywhere, and everyone and every device is collecting more data than anyone can actually make sense out of that. If you think that positively, you can link all those data together and think about between people, data, and all those things, you might be able to figure out the relationship. As Satya this morning mentioned about, you could think about the kind of graph. But the fundamental problem is really how much we can actually even know about the kind of data there. I want to be very clear with you that as we think about all this kind of machine learning kind of problems that we can actually solve, there are different ways to think about that. We actually build a product in Microsoft called Azure Machine Learning. In fact, tomorrow, my colleague Joseph Siroshi will talk about in great details in his keynote tomorrow of what kind of machine learning tools we can do. You can even imagine that a Project Oxford can be part of the overall machine learning tools that Microsoft will provide to you. And what we really want to talk about here is actually all kind of multimedia data, as I mentioned, that audio, video, image, text, what kind of things we can actually do. I want to get even more specifically the kind of data that we actually deal with. The first kind of data is actually vision, with all kind of image and the video thing what we can really do. I actually started my own research career doing computer vision stuff. Imagine that 50 years ago, Marvin Minsky in MIT just said that why don't you just connect the camera to your computer, then let the computer tell you what the computer really understands. So things has really progressed a lot over the years. Especially the last 5 years, computer vision has really advanced a lot. And similarly, of course, for speech, which I also mentioned very quickly. I think a significant reason for that recently, I would say there are probably two. One is there's just so much more data. Secondly, I would say a lot of machine learning algorithms, particularly deep learning, are making huge difference. The second set of things we want to talk about today is actually about the face. And if you look at the face, and you could view that as a specific part of images, but they are just so special that there's so many things you can actually do. And whether it's face recognition or ID or detection and other things. The third one is speech. I still remember 20-some years ago, speech was very hot. And that was around the time that the hidden Markov model started to really show the promise. And if you plot all the error rates over the years, speech recognition error rates, coming down, it really took a lot of years. That, roughly about 20 years ago, it was golden age for speech recognition. The speech recognition rate really went down significantly. But then there was about 10, 15 years of time that the speech was not really making too much progress there. Last 5 years, we once again witnessed the unbelievable improvement of speech. We're getting to a point that speech recognition is becoming mainstream, is becoming useful, and we have had a number of years of investment in Microsoft. Is something that I feel very, very excited about, what we can actually offer to the users and the developers, I should say. The last one we will talk about today is perhaps the thing I feel most excited about is actually about language understanding. It's great to understand the phrases and the words in speech, but when you put those things together, and the language understanding is very, very difficult. And as some of you might know, that Microsoft recently announced the Skype translator, where we actually have a machine translation that started from the speech. Then you have some natural language understanding. Then you need to have the context. You put those in together. So today we will show you a teaser of what's really interesting you can do by actually training your own natural language understanding model, in particular, using something called active learning with small amount of data to start your process there. So Ryan will tell you a lot of those details there. So you might ask, say, why now? Why Microsoft? Well, because we actually have really been working on all kinds of machine learning modules for all kinds of multimedia data for a long, long time. And we actually started in the speech recognition group 23 years ago, started vision group 20 years ago in Microsoft Research. And we have trained tons of different models, not only for research projects, but also for various products like Bing, Cortana, Xbox, Office. So we realized a couple of things. One is that even at the Microsoft, we cannot really require every developer to be machine learning experts. Secondly, we also realized that many different companies, many different research institutes coming out with very interesting advanced algorithms for visual recognition, visual understanding, speech, and all those things. But it's really important that we make those advanced algorithms, advanced prototypes and tools available to a larger ecosystem as people continue to contribute to those algorithms such that we can actually share with everyone. And then we can build interesting apps, not only for Windows, but across all kinds of ecosystems, as you heard from Satya this morning. So that's why we started this Project Oxford not too long ago, and we start with a set of web services, REST APIs, such that anywhere, any web service that you build, we can actually help you to start with. Yet, make no mistake, we want to have the right binding of this kind of web services with all kinds of clients, and hopefully, we will be able to continue to deliver this kind of value to you. Since we're talking about the developers, a key requirement for any kind of API design or those SDKs is really easy to use. So we keep this very much in our minds as we started designing this whole thing. My joke to the team is that you just have to design the whole API system so simple that even Microsoft executives can use it. So I'm going to personally demonstrate, show you a demo that actually I wrote a few lines of code. And on this Android phone, I will show you a demo. Let me switch the display first. Great. I see you can actually see that. So it's actually really fun demo, and I just give you a little bit of context and a little bit of marketing-ish, but bear with me. So my boss, the CEO of Microsoft, Satya, is actually a cricket fan. So he actually follows some exciting cricket games, like World Cup. Unfortunately, I actually don't know anything about it. I spend too much time watching American football, I guess. So But I have technology, and we have Project Oxford. We have all those visual recognition and the speech and other things. So then I thought maybe I just build a very simple app using this kind of APIs. So here's the app. Let me show you a demo here. So I can start this and try to recognize a couple of all cricket players, and which I actually care about because I know Satya follows those guys. So if I just input a picture, let's say I watch TV and the game is going on, I snap the photo, and from that I actually have a picture of some people, actually players playing, but I really don't know those guys. But I can submit this picture to the kind of web services that I built using Project Oxford's APIs, and I submit that. So now this picture is actually going there. As you can see very quickly, and those two people are identified, and with their names. Again, I want to tell you that those two names are among a group of names that actually I wanted the system to recognize. So then I say, I actually want to know more about VRED. So what I'm going to do is actually now I connect VRED to the Bing search engine. So now it's actually sent to the Bing search engine. What's different here is that I actually enhance the Bing search result with another set of API services powered by Project Oxford. That is actually speech. So let me see if it works here. You probably see this microphone symbol here. So I press this. So I just want to know more about VRED. So how old is he? Well, it's pretty good. No, he's only 26. Wow, he's doing really well. Maybe give another try. Where was he born? All right. So you can imagine that with this kind of web services you add on here, and you can do a lot of interesting interactions. So again, I think the point is that how can we really think about offering this set of APIs from speech to vision to face to language, so that we can help you, the developers, to add the smarts to the data and the application you're building. So with that, I'm going to invite Ryan to come up to tell you a lot of the glorious details. Ryan, please.
Thank you, Harry. Hi there. So my name's Ryan Galgan. I'm a program manager in technology and research. I'll tell you a little bit more about the services that we're announcing today with Project Oxford. So first off, I just want to come back to Harry's mentioning earlier about how ease of use and how that was kind of a guiding principle for our services. So as we built these APIs against kind of Harry's joke about so easy that even a Microsoft executive can use it, things like detection and identification, very, very complicated models in the back end, very hard to do. But with just 2 lines of code, we have 1 line for detection, 1 line to identify it. Make it very easy to include these in any application. So let me talk a bit more about which services we'll be talking about today. So within Vision, we have a set of services so that you can understand and recognize the contents of images. We also let you identify words within those images. And finally, we help you generate thumbnails that keep more of the content within your cropped photos. Face APIs, this is a complex and specialized set of tasks within Vision. And we provide a set of REST APIs so that you can not only detect faces, you can describe faces, you can even predict some features about those faces, but we also let you take a set of photos that you've never seen before, you've never labeled, and we'll group them around the people that are in those photos. And finally, we provide the set of tools so that you can do identification, task that Harry just demoed in his application. With the speech services, we provide you the ability to both hear your users and talk with your users. With speech recognition, you can convert audio into text. With the text-to-speech, you can easily generate audio files to speak back to your users, all across multiple languages. And finally, Lewis, we'll touch on at the end. Lewis helps you really understand the intent behind words and behind phrases. So you can understand not only what set of actions you want to take, you can also say what topics you'd like to take those actions on. And really, with the power of active learning, Lewis makes it easy for you to get a model started, host it, and building your application around it. So first, with the Vision APIs, we've built these in collaboration with the Bing team. And these help you make the most of your images and understand what's happening inside of them. So the Analyze Image service provides a set of features that describe an image and is built specifically with the Bing image search team. So on the left-hand side of the screen, you can see an input photo. With just this photo input into the Analyze Image REST API service, we can start to describe what type of image is this. Is it a photograph? Is it in black and white? Is it in color? Is this animated? Is it a line drawing? Is it clip art? Things like that. Content is where we're really drawing on Bing's image understanding. So the first item you'll see there is categories. So given just this photo of a man swimming, we can return back and say, well, it really looks like this is someone swimming. So whether or not, or whatever the photo ends up being, we can tell you there's a cityscape, there's cars, there's a cat, there's a dog. We can help you describe the image with only the image as the input. We have a set of scores around adult content, so you can understand if there's pornographic content within a photograph. This can be very useful if you're doing some sort of content moderation. And finally, faces, which makes use of the face APIs, which we'll talk about in more detail later on, lets you understand how many faces are in a photo, as well as predicting the age and even the gender and the location of where that face is found within the photo. The final set of features I'll mention from this Analyze Image service are colors. So we can describe with this service, what are the dominant colors in the front of the image and the back of the image. We can also tell you what the accent color that would work best with the image is. So by knowing this color information about an image, you can make it look beautiful within your application without having to do a bunch of custom work for each individual photo. The Object Character Recognition service lets you identify and recognize words within a photo. So with this example on the left-hand side, this was the only input into the REST service. And not only does it recognize the total text within the photo and where the line breaks are, but it can also predict what language this seems to be, what orientation the words exist in. And it can give you a bounding box so you can recognize within the photo where each of the individual words ends up being. With the Smart Thumbnail service, we often have a need to crop or scale photos. But when you do that, it can be challenging to make sure the important content remains center of the frame. On the left-hand side, you can see two sets of input images. And on the right-hand side, you can see multiple different croppings for these images. So right now, you can see that the dominant object in both of those photos can sometimes be lost, especially in the rightmost side, where we have kind of the most aggressive cropping going on. So when we run these photos through the Smart Thumbnail service, switch to here, it keeps more of the content within the frame. So let me go back just to show that again. So here, which is kind of a naive cropping, we start losing some of the content in the photos, especially if you look at the rightmost items. But through the service, we now shift it and keep that front and center. This can be really helpful when you're trying to put photos in multiple spots in your application. With the face APIs, this is a set of computer vision tasks that help you recognize human faces within images. So the first one we'll talk about is just detection. This is one of the core calls that a lot of the other features of Face API builds on top of. So here, given an input image, this example you can see on the left, we get this output, this nice JSON object on the right. So first detection looks for one or more faces within a photograph. And not only does it detect that face and tell you how many it found, where within the photo that face is found, but it even tells you, what is the pose, where is the person looking. It also predicts things like age and predicts things like gender. So these are a set of experimental features that we're surfacing with the Face APIs today. But these will evolve over time and improve over time. Finally, it gives you a set of facial landmarks. So with the facial landmarks, you can tell where the eyes are, where the nose is, left side of the mouth, right side of the mouth. You can just understand kind of all these points across the detected faces. Now, if I switch over to verification, so verification builds on top of detection. With verification, you give two input images, it detects faces, and then it compares the two to see whether or not they're likely to be the same person and gives you back a confidence score for that. Grouping, this continues to build on top of detection, and the grouping API call takes in a set of images and returns back those images clustered around the detected face within those photos. So with no extra information, this is kind of the start to being able to tag collections of photos. So moving on to identification. So identification is a slightly more complicated task, but we provide a set of APIs that makes this easy to build within your application. So the first thing you'll do if you want to start identifying faces within a photo is you'll create a group of a person group. So in this example, I've labeled it colleagues. Then for each person group, you can go in and you can add one or more person objects. You can describe what that object is. So in this case, I've added one of my colleagues, Chow. Now, when we go back to the detection call that we talked about earlier, at the end of that call, you're given the opportunity to basically add that face to an existing person object. So over time, with a couple of detection calls, you can build up a set of example faces for each of the person objects in your group. Then you can make the identify call, where you take a new unlabeled photo, you pass it in against your existing person group, and it will tell you, which person object is this most likely to be, or if it doesn't match for any of them, it will tell you that it's an unknown face. So let me switch over to the speech APIs and talk about how we can help you understand the content of audio. The speech APIs, powered by Bing, we provide two main services. The first is voice recognition, which converts speech and spoken audio into a string, and voice output, so you can specify what type of audio file you would like to generate. With voice recognition, you pass in an audio stream or a file, and you get back a set of text strings. This is the same backend that powers Cortana's great speech recognition. And at launch, we're announcing this with support for multiple different languages. With voice recognition, there's two main modes that this works in, a short form and a long form mode. Short form is really when you think users are going to be issuing single sentences, little 15 seconds or less kind of utterances to your application. And you can see an example on the bottom of the screen. So if the input to this was 456th Street, San Francisco, the short form service returns back and says, well, here's a bunch of translations. And it'll even come back and say, there might be multiple translations for this or multiple transcriptions for this. So here are kind of the 5 most likely ones. In long form mode, this can deal with audio files up to 2 minutes in length. And it returns back strings at each identified sentence pause from the service. Now, in both of these examples, you can also make use of what's called partial results. So when you call the service, you can tell it, instead of just giving me the final result, as you're in the middle of processing this audio file, give me results along the way. As to how you access the voice recognition service, there are 2 main ways to do this with Project Oxford. The first is a set of REST APIs, and the second is a set of client libraries that we publish for Windows Desktop, Android, and iOS. Both get access to the same backend, but the primary difference you'll notice between the REST API and the client library service is that when you use the client library, this enables you to do the long-form audio processing. In addition, the client library is what enables those partial results to come back. And this is because the client library is making use of a WebSocket connection, so it can keep streaming those results back as it's making progress on them. Now, I'll also talk briefly about Windows 10, which has a set of speech APIs built in. So the speech APIs in Windows 10 provide an even further enriched set of speech features, things like voice activation, or dealing with microphone array processing, or extensible grammar controls specific to your voice recognition needs. So with these 3 different ways of accessing voice recognition services, it was really up to you, the developers, as to what best fits your application, what best fits your needs for what features you need supported. And on the Project Oxford website, we end up having sample code and some descriptions in a bit more detail as to the differences between these 3 different ways of doing voice recognition. Voice output lets you actually now talk to your users. So you can generate files 15 seconds in length, and it has multiple languages that support, 17 actually at launch. And across those 17 languages, many of them have both male and female voices. So depending what type of audio you'd like to send to your users, you can pick that. And along the bottom of the screen, this continues with our kind of ease of use description. So all I have to do when I call the voice output service, I pick the language I'd like, I pick which voice I'd like it to use, and then I just pass in the string, and it returns back an audio file. So let me quickly switch to the Project Oxford website, and I'll show you an example of these two services. So first off, we'll have our speech-to-text service here. Happy to be at Build in San Francisco. Stop listening. Great, it's transcribed the text. And as it was going, you could see that the words were adjusting and shifting themselves over time. That's the partial result at work. Similarly, with text-to-speech, we can type in the text that we'd like to have. And then you can even see that in this case, all we've specified call is that the language is English, and we'd like to use this voice. And we hit play.
Hi there, and welcome to Build.
Great. So it's very easy to start having dialogues with your users with audio and understanding what they're saying. I'd now like to switch to LUIS, which stands for Language Understanding Intelligent Service. I'm really excited to show you how LUIS can bring natural language processing into your applications. So just as voice recognition was able to convert audio into text, LUIS lets you convert that text into a set of structured understandings. So you can take this phrase like news about flight delays, and you can get back the structured response on the right that ends up saying, not only is find news the most likely intent, but that the topic that we want to operate on is flight delays. So with LUIS, you can build this type of model for yourself and for your application by providing just a few examples with labels. So now let me switch to the browser, and I'll show you how easy it is to end up actually building a LUIS model. So first off, at launch, LUIS is going to be in private preview. If I sign out, this is the page you'll see when you visit the LUIS website. And first off, as a private preview, which means we're not letting everyone into the site at first. So you come in and you sign up for an invite code, and you give us a few examples of what you'd like to use LUIS for. And then over time, we'll be letting in more and more developers to the service. And this is really so that we can get feedback from the developer audience as to what changes you'd like to see in LUIS, what's working, and what's not. So I'll sign in to LUIS. And now I have in mind an application that I'd like to build around being able to find, send, share, and read news topics. And I want to be able to access this application. I want to be able to let my users interact with it via audio. So the first thing I'll do is I'll say, new application. We'll call it news chat. Find, share, and send news. And read news. LUIS will create a new application for me. And once it's created, I can then come in, and I can choose to edit the application. Now, with LUIS, you'll notice on the left-hand side of the screen that there's intents and entities listed. So intents map to actions and full sentences in the app. So in my application, I want to be able to find news. I want to be able to share it with someone. And I want to be able to read a specific item. And the entities, in this case, are the objects we take those actions on. So when I go to find news, I want to find news about a topic. If I want to send it to someone, I want to send it to a specific person. So the first thing I'll do is I'll define some entities. So when I go to send, I want to be able to have a recipient. And when I go to find news, I want to have a news topic. Similarly, we can go up here and we can create those intents. So I mentioned we have share news. We also have find news. Finally, we'll have read news as an intent. I'll clear these notifications. And now that I've told LUIS, what actions I'd like my model to understand and what type of entities I'm going to look to get back, now we switch into this main tab and this new utterances area. This is where you start giving LUIS examples, and you tell LUIS, this is what I'd like to handle, and this is how I expect users to interact with my application. So find news about Build. So the first thing that I'll do when this comes up is in this drop-down box over here, I can pick what intent this phrase matches to. So finding news, this is a find news intent. And then in the phrase that I've typed, I can select any of the words, or really any part of the string I can drag and highlight. And then I can say what entity this is. So find news about build. Build is the news topic. So I'll label that, and I'll click submit. I could try another way of asking for news. So tell me news about California. Again, I'll come over here. I'll say that this is a find news example. California is a news topic, and I'll submit this to Lewis. Now I can give some examples of other intents. So share with Jim. We'll say that this is a share news intent. Jim is the recipient. And now, one of the things that tends to be very valuable for model building is providing negative examples. So something that I know that this model should never identify with an intent. So just one example is, what is the population of Seattle? This is something my news finding app will never understand. So it's pre-labeled as none here, and I can just hit submit. Now, you've seen me add a recipient and a news topic. So I've defined 2 types of entities that are really important to my application. But when I think about how I want the app to be able to read news, so I want users to be able to say things like, read the third item. So third in that case would be the way that I want to select an item from the list. But with Lewis, we have a set of pre-built-in entities. And these are coming from Bing. So for a lot of common use cases, we provide pre-built entity understanding models so that you don't have to worry about defining these yourself. So everything from being able to understand temperature, at the bottom here, being able to understand dates and times. These are things that Lewis comes ready to help you with if it's an important entity for your application. Even something like this encyclopedia entity identifier, this is preloaded with thousands of different entities and topics, locations, places, things like that. And this can be a massive time saver when you're trying to build a model. So I'll come back up here, and I'll select ordinal, because this is how I'm going to refer to things in my application. So now, when I come in and I say something like, read me the third item. It's a similar window that you've seen before, but because I've said ordinals are important to my application, it's already labeled that third is an ordinal. So all I have to do is say, this is a read news intent, and I'll submit that. So now you'll notice along the bottom of the screen that Lewis has already picked up and started training. So it says, look, you've entered in a few utterances. I'm just going to train a model for you. So now what happens when I come in and I say, find news about Azure. So in this case, just with those couple of examples, this was enough to get a model built in Lewis, and it can start trying to match these utterances. So now find news about Azure. So it's already said, look, I think Azure's a news topic. And I'm pretty sure, or I'm very sure, that find news is the intent. So we can hit submit there. Similarly, we can say things like, we could say, tell me about Seattle. Again, find news. It is labeled this intent. Didn't quite get the entity, so we label this as being a news topic. Submit. So now I've labeled a few utterances. Retrain the application manually. And I'm ready to start trying this out. So I come back to the My Application page, and now this Publish button is available. So if I click Publish, which is a web service, what's happening here is Lewis is going and is taking the model that I've trained, and it's hosting it for me. And it's giving it at this endpoint that I can start hitting over HTTP. So now I can type something like share with John. We'll click this. Even a little bit bigger. And now you can see this is the response I get back from my model. So share news is the highest ranked intent. I didn't quite get the entity there, but that's OK. I'll show you how we can go back and adjust that later on. We can try a few more examples. So share with John, so we can say find news about cricket. And now in this case, Lewis has predicted the intent as find news, and it's pulled out cricket as being the news topic that I'd like to work against. So you can see how in my application, as soon as I see this as find news, I can take this entity that is identified, and I can just start operating on that directly. I don't have to do a lot of extra work to try and figure out what that entity ends up being. Now let me give you an example of something that I'm pretty sure this Lewis model is not going to have generalized to yet. So when I go to share, I think people might want to be able to say something like shoot that to James. So Lewis has returned, hasn't identified any entities here, and in fact it said that the most likely intent in this case is none. None is this catch-all bucket that says, look, this doesn't seem to match any of the other intents that you've previously defined for me. So I will now come back to Lewis. We'll close this window, and I'll come into Edit. And now in this main page, if I come up to the Suggestion tab, so now you're going to see, all these, the three utterances that I've issued against the application already, or against the model. And these aren't necessarily going to be in the exact order that I've issued them against the application. And the reason for this is thanks to active learning. So what Lewis does is it orders these based on the ones that are most likely to improve the model. So the ones at the top will end up improving the model the most if I label them. And doing this by hand here, where I've labeled 3 or 4 of them, it's not too hard. It's very quick and easy to label these utterances. But once you've built kind of an initial model into your application, you've shared it with a couple of people, and maybe you're getting hundreds or even thousands or tens of thousands of utterances coming in a day. This is one of the biggest time savers of Lewis. So it always puts at the top the ones that are most important for you to label to make the model better. So when you have some time to go in and label those, you're always working on the most impactful ones. So this is the same interface that we were showing before. So shoot that to James. I'm going to say that this is share news, and I'll say that James is a recipient. So we'll submit that. Share with John. John is a recipient, but share news was already predicted correctly. And find news about Cricket. So this one was labeled correctly, both in terms of the intent and the entity. So I'll submit that one. Now the one thing on the left-hand side that I haven't shown is model features. So model features are a way to tell Lewis there's a set of words or there's a set of phrases that are really important to the application. These are hints. If you see any of these words, you see any of these phrases, pay closer attention to that word or phrase. And so in this case of being able to share news and wanting to identify a recipient, maybe I say, look, I have a set of names, and names are really important. So I can say names list. And I can just take a list of names that I already have, add them in as a comma-separated list, and tell Lewis, here's a set of features you should really think about and treat as stronger hints. So now if I come back to new utterances, and I say something like, shoot that to Amber. So great, share news identified as the strongest intent. Amber identified as the most likely recipient. I can submit that. And we can even try a few more here, such as find me news on Office. Find news, again, the correctly predicted intent. Office is now the entity, and we hit submit. So you can see that over time, you kind of come back and forth with Lewis. You label a few more utterances. It builds a new model for you. You try that out. You see how that's doing. You see what users are submitting. And you keep kind of updating this over and over again. And whenever you want to, you come back to the My Applications page. You choose Publish. And you can update the published application. And now all of a sudden, shoot that to Bobby. Do that. And it will have published the updated model, and it's found share news, and it's found Bobby as the correct recipient. So that's how easy it is to end up building a model with Lewis. So just giving these few examples that you want your application to handle, giving a few utterances, Lewis provides a model for you. And with the active learning that I talked about earlier on, Lewis is always making the time you put into labeling the most valuable time that it could be, because it only provides the ones, or it provides the ones at the top of the list that give the model the most information. So that's the set of services that we are announcing today for Project Oxford, and I want to show you how to get started with these. Lewis, as mentioned, was a private preview. All the other services are actually available in beta starting today. So we switch over to a browser, and we can come to the Project Oxford website. And on our website, you can find our demos and our documentations, which we've talked about a little bit before. But let's say I'm interested in the speech APIs and signing up for those. So when I come to the speech API page, just click Sign Up. This will take me over to the Azure Management Portal. So all of our services make use of your existing Azure accounts and subscriptions. And once this loads the marketplace, we come in and we've got 3 entries, a face API entry, speech entry, and the vision API entry, and you'll pick that from the list. Once you pick it from the list, give it another moment here, see if it comes up. Great. So I can come in and I can say that I want access to face APIs. Make sure, give it a name so it's identified by our service. And as I mentioned, all of these are available starting today in beta. We're providing a free tier of access for all of these that gives you 5,000 transactions for each of the APIs each month. So a transaction is roughly, every REST API call counts as 1 transaction. Click Next. It reviews the purchase, asks me whether or not that I'm OK with it being a free purchase. This is where you can find our terms of use and privacy policy as well. And once this is done, it will let me purchase this, and it'll show up in my list of applications. So now I can go to one that I've already created. And once you've added this to your Azure account, you need to get your API token. So this is how you actually, the secret key you include in your REST call so it knows that you're authorized to use it. So you manage all of these on our Project Oxford page. So you can see I have this older one here called Speech APIs that I've already purchased. And my primary key and secondary key you can show, and you can regenerate these and use them as needed within your application. So again, Microsoft Project Oxford. So this is this collection of REST APIs that we're proud to announce today. And we want this to help you developers to be able to write smarter applications. Don't need to be an expert in machine learning. Don't need to be an expert in some of these advanced vision and speech recognition tasks or natural language processing. So we just help you easily understand that content in your applications, especially as this content starts being more and more readily available. We're all carrying around 1, 2, or maybe even 3 devices in our pockets that's got a video camera, that's got a microphone in it. So being able to unlock what's in that is an incredibly powerful task. This is a constantly evolving set of services as well. So I've talked about the set that we're announcing today, but your feedback is going to be very important to us as we figure out what are the next set of services we launch. So I have a few requests for you. So go to our website. So you can find it at www.projectoxford.ai. Stop by our booth. We have a booth on the 3rd floor. There we can help you get you registered with any of the services. We can answer questions. We can get you signed up for Lewis for an invite code, so you can be one of the first users to make use of Lewis. And as Harry mentioned already, this is his first step. So we have forums. Come give us feedback. Tell us what extra features you want to see. And finally, with the Vision APIs, I only touched kind of briefly on the set of services that exist in the Vision APIs and the features that come out of them. So on Friday, there's a talk from Manaz on the Bing team, and he'll be going into much more detail as what those services are. So that's it today for our talk. So kind of a final reminder, as Harry mentioned in the beginning, please evaluate the session. Tell us how we did. And again, stop by our booth. Let us know what you think about Project Oxford. And we're really excited to see and hear what you build with these sets of services. Thank you.